Well, here we go again. Back to injector testing. As you can see, I've got the injector test rig back out. I've bought a few just cheapy valves just for the test rig. Actually using some different methods this time to test cones. I'm just at the moment testing the lift potential using different ratios between the combining cone outlet and the outlet of the steam nozzle. And then once I've done those, I've got a few experiments to do with those different ratios. I'm actually finding there's quite a drastic difference as you up the size of the outlet of the combining cone hole, the amount of lift the injector can achieve, which kind of makes sense as in the lifting phase the injector is a venturi tube before the condensation of the water happens, which obviously draws more water in. Once these experiments are done, I've then got the test condensing cone. Quite hard to see, I know. The test condensing cone, which I am trying to ensure the overflow gap, which you can see through there, remains dry. Yeah, quite a lot of different iterations. I've got a whole box of cones here that have been tested or whatnot. I'm just turning this cone down now on a tapered arbor. This is the best way I've found. Once you machine them from one side, this is the best method to create or bring them down to length, I should say, which obviously changes the diameter of the outlet hole, which changes the lift, and then also changes the requirement of the combining cone entrance diameter. As I said a few videos back, I'm intending to write a book on this. I'm gathering all the data. I'm doing a lot of research online. So yeah, there will be a book eventually. It's just going to take a lot of years of iterations of this. Bob Branson did a good book, but his book only went up to around 130 psi, was the maximum he ever experimented in his book with. I'm looking for from 130 upwards to around 200, 250. So my aim is really to make the high pressure model steam injector. Putting these on a machined arbor really is the best way I've found of making the outlet, or ensuring the outlet rope is axial with the injector. I found parting them off can leave burrs on the outlet, which when you then try and take off with I don't know, say a tiny little you can't even see it so small, a tiny little centre drill or something like that, you can affect the outlet. As you can see, it's within 0.01 of run out, which I found is completely acceptable on these model injectors. Plan is to take this one down to 4.66 millimeters long. This is 6.1 millimeters from a previous experiment. I'll take this down to 4.66, and then yeah, I'll record the results, as you will see. So for that test, as you saw, the overflow went dry at around 135, 140 psi. I actually want this injector to work down at 130, and that is my baseline injector, which means I'm going to have to change something. Now, you didn't see it on camera because, as you saw, it's so bloody messy. I was measuring the temperature and it was coming out around 66, 68 degrees, which is a little bit low considering the water temperature at the minute out of the tap is around 22. Means I kind of need to up that discharge temperature from the combining cone out to around probably up around 70, 75 I'd want to see. So what I'm going to do is I'm going to repress the combining cone in, reduce how much I press it in by around 2 thou, and then we'll go again and we'll see how the temperature changes. Well, you probably won't see it on camera because I won't be able to measure it and film it, but yeah, I'll let you know how that 2 thou changes the temperature and whether that lowers the point at which overflow 1 goes dry.